Good day, everybody. How are you all? This is Dr. Nandi. Today we are going to talk about hypothesis testing. So here I go. Hypothesis testing with one sample. The actual test begins by considering two hypotheses. What is hypothesis? It's an educated guess. They come in pair. Okay. One is called a null hypothesis, the opposing viewpoint is called the alternative hypothesis. So null hypothesis is the status quo statement. It's usually a statement about a population characteristic or a population parameter, such as the population mean. Okay, and the alternative hypothesis is also a statement about a population parameter or population mean, for example, related to the null hypothesis, but they are opposing. Okay, so one, for example, the null hypothesis can be equal to a value, the mean equal to a certain value, alternate the mean not equal to that value. So H sub 0 is the null hypothesis. It is a statement about the population that either is believed to be true or is used to put forth an argument unless it can be shown to be incorrect beyond a reasonable doubt. And what is H sub A is the alternate hypothesis. It is a claim about a population that is contradictory to H sub 0, to the null hypothesis, and what we conclude when we reject null hypothesis. Point to note, null hypothesis contains an equal to sign, alternate hypothesis may or may not, will not never contain an equal to sign. Okay, it can be not equal to, as you will see, or it can be greater than, or it can be less than, but never contain an equal to sign in the alternate hypothesis. Since the null and alternative hypotheses are contradictory, you must examine the evidence to decide if you have enough evidence to reject the null hypothesis or not. The evidence is in the form of a sample data. So if you reject null hypothesis, that means you have enough evidence to support the alternate hypothesis. After you have determined which hypothesis the sample supports, you make a decision. There are two options for a decisions. They are reject null hypothesis if the sample information favors the alternate hypothesis, or do not reject null hypothesis if the sample information is insufficient to reject the null hypothesis and therefore to support the alternate hypothesis. In this chapter, we conduct hypothesis test on a single mean, mu population mean, and single proportion, p population proportion. Mathematical symbols used in H0 and HA. H0 is the null hypothesis, HA are as follows. HA never has a symbol that contains an equal to sign. As I mentioned, the equal to sign is only in the null hypothesis. Note, H sub 0 always has a symbol with an equal to sign in it. H sub A never has a symbol with an equals in it. The choice of the symbol depends on the wording of the hypothesis test. However, be aware that many researchers, including the co-authors in research work, use equal to in the null hypothesis, even with a greater than or less than as the symbol in the alternate hypothesis. This practice is acceptable because we only make the decision to reject the null hypothesis or not reject the null hypothesis. So if H sub 0 is equal to, alternate hypothesis is not equal to. Remember, alternate hypothesis can never contain the equal to sign. So either it is not equal to or greater than equal to, or greater than or less than. Never equal to sign in the alternate. Again, null hypothesis equal to, alternate can be not equal to or greater than or less than. Null hypothesis can be greater than equal to, in that case alternate is less than, Null hypothesis can be less than or equal to, always an equal to sign in the null hypothesis. Since the null hypothesis is less than equal to alternate being contradictory will be in that case greater than or more than. H sub 0, no more than 30% of the registered voted in the Santa County voted in primary election. No more than. This means H sub 0 P less equal to, I would not write 30, I will write 0.3 because 0.3 in decimal is 30%. Then the alternate will be H sub A P greater than 0.3. We want to test whether the mean GPA of students in American colleges is different from 2.0 out of 4. Alternate in that case is H sub A mu not equal to 2.0. Null hypothesis equal to 2.0. Why is the alternate not equal to? Because we do not know whether it is greater than or less than. We want to test example 9.3. We want to test if college students take less than 5 years. So alternate mu less than 5 years. Null hypothesis in that case mu greater equal to 5. Equal to sign always with the null hypothesis. A medical trial is conducted to test whether or not a new medicine reduces cholesterol by 25%. Okay, state the null and alternative hypothesis reduces by 25%. Alternate P, okay, P greater than 0.25. Alternate null hypothesis P less equal to 0.25. It can be also null hypothesis P equal to 0.25. Alternate P not equal to 0.25. We want to test whether the mean height of a 8th grader is 66. Null hypothesis mu equal to 68. Okay. Alternate mu not equal to 0.66. Okay. When you perform a hypothesis test, there are 4 possible outcomes, means results, depending on the actual truth or falseness of null hypothesis, H sub 0, and the decision to reject or not. Okay, so look at this table. The outcomes are summarized in the following table. So action means the decision we are taking. That's in the first column. What is the state of the null hypothesis is in the second and the third column. Second column, H0 is actually true. That is the state of the null hypothesis. In the third column, H0 is actually false. So what is my decision? Second row, do not reject H0. Let's look at the intersection of do not reject H0 and the second column, which is H0 is actually true. We do not reject H0 and H0 is actually true. Intersection of the second row and the first column. H0 is actually true and our decision do not reject H0. We made the correct decision. Then we look at the intersection of the second row and the third column. H0 is actually false and we do not reject H0. That is our decision. So fail to reject H0 when H0 is false, that's a type 2 error. Okay. Then we look at the second row of decision, which is reject H0. Look at the intersection of second row and second column. H0 is actually true. Okay, so that is H0 is actually true, but we reject H0. We made a type 1 error. So what is a type 1 error? Reject H0 when H0 is actually true. Type 1 error. Intersection of the second row and the third column. Reject H0 when H0 is false. We made the correct decision. Each of the errors occurs with a particular probability. Alpha is the probability of making a type 1 error. Okay. Probability of type 1 error is alpha. Alpha is Greek small a. What does it mean? It's probability of rejecting H0 when H0 is true. That means in reality, we should not have rejected H0, but we made an error, which is called type 1 error. And what is beta, that is small Greek b, is probability of making a type 2 error. What is type 2 error? failing to reject H0 when H0 is false. Alpha and beta should be as small as possible because they are probabilities of errors. They are rarely zero. Suppose the null hypothesis H sub 0 is the victim of an automobile accident is alive when he arrives in the emergency room of a hospital. Type 1 error, reject H0 when H0 is true. That means the victim is alive, but the emergency room technicians think he is not alive. The emergency crew thinks that the victim is dead when in fact the victim is alive. That's type 1 error. What is type 2 error? Failing to reject H0 is false when H0 is false. What is that? The victim is not alive, but the emergency crew people think that he or she, the victim, is still alive. The emergency crew does not know if the victim is alive when in fact the victim is dead. Alpha is the probability that the emergency crew thinks the victim is dead when in fact he is really alive. That is the probability of type 1 error. And what is beta? Probability that the emergency crew does not know if the victim is alive. Failing to reject H0 when H0 is false. In fact, the victim is dead. Probability of type 2 error. The error with the greater consequence is the type 1 error. Reject H0 when H0 is true. The patient is alive, but you think the patient is not alive. Okay? If the emergency crew thinks the victim is dead, that is not alive, they will not treat him. That's a greater consequence. So that's why type 1 error is more serious than type 2 error. Okay? To perform tests for a population mean mu, we use either a normal distribution or a student's t distribution. Both should have data that come from a simple random sample that comes from a population. Remember, a student's t distribution is used when the population standard deviation is unknown and the distribution of the sample mean is approximately normal. We should also check that our sample size is large enough. Question is, what is sample size is large enough? Usually n should be 30 sample size. The distribution for the test is the normal distribution of X bar or sample means, which is a bell-shaped distribution with a mean equal to mean of the population. We are looking for the sampling distribution of X bar or the probability distribution of the sample means, which is a mean equal to mean of the population and standard deviation equal to standard deviation of the population divided by square root of the sample size. Okay. Or T alpha. The population parameter, population characteristic is mu. The point estimate for mu, single value, is sample mean X bar. We will use z-test or t-test on the graphing calculator. To perform test for a population proportion, we use a normal distribution. Usually the sample size n is large enough. We must check that n times p greater than 5 and n times q greater than 5. What is n? N is sample size. What is p? Probability of success. What is q? Probability of failure is equal to 1 minus p. So in when n times p and n times q are both greater than 5, then the sampling distribution of p prime, which is the sample proportion, follows a normal distribution with a mean equal to the mean of the population and the standard deviation equal to square root of p times q divided by n. Okay, remember that q, which is the probability of failure, is 1 minus p. The population parameter is p, population proportion. The point estimate for p is p hat or p prime. P prime is given as x over n. X is the number of success and n is the total sample size. We will use one prob z-test on our calculator. Use the sample data to calculate the actual probability of getting the test result, also called the test statistic. Remember, statistic is a characteristic of the sample. So test statistic is a characteristic of the sample that we have collected. We calculate that from the calculator. And then we calculate a p-value. What is a p-value? P stands for probability. So it's a probability value that if the null hypothesis is true, the results from another randomly selected sample will be as extreme or more extreme as the results obtained from the given sample. Okay. A large p-value calculated from the data indicates that we should not reject the null hypothesis. The smaller the p-value, the more unlikely the outcome, and the stronger is the evidence against the null hypothesis. We would reject the null hypothesis if the evidence is strongly against it. Good news, we'll use the graphing calculator to find the p-value. Again, p-value is what? It is the probability of obtaining a test statistic, which is a characteristic of the sample that we have gathered, as extreme or more extreme than what we have collected. And if the p-value, probability value of the test statistic is very small, then stronger is the evidence against the null hypothesis, and we reject the null hypothesis. A systematic way to make a decision of whether to reject or not to reject the null hypothesis is to compare the p-value and preset or preconceived alpha. Remember, alpha is the probability of making a type 1 error, and alpha is called significance level. Usually, alpha is given in the problem statement. It is usually set at 0.05. That means the probability of making a type 1 error is fixed at alpha equal to 0.05. What does it mean? It means we are taking 5% risk in rejecting H0 when it is really true. That is, we should not have rejected, but we are taking a 5% risk of making a wrong decision. If p-value is less than alpha, then we reject H0. The result of the sample data is significant. There is sufficient evidence to conclude that H0 is an incorrect belief and that the alternative hypothesis may be correct. If p-value is greater than equal to alpha, do not reject H0. The results of the sample data are not significant. Okay, there is not sufficient evidence to conclude that the alternate hypothesis may be correct. When you do not reject H0, it does not mean that you should believe that H0 is true. It simply means that the sample data have failed to provide sufficient evidence to cause serious doubt about the truthfulness of H0. That is why we never say accept H0. If the p-value is greater than the level of significance, we do not reject the H0, but we never say accept H0, because H0, we do not know whether it is true or not. It is just an educated guess. Here's a memory device that may be helpful. If p-value is low, the null hypothesis must go. Reject it. If p-value is high, null hypothesis must fly. Do not reject H0. If a boy genetics labs claim that their procedures improve the chances of a boy being born, the result for the test of a single proportion are as follows. Null hypothesis p equal to 0.5, alternate p greater than 0.5. Alpha is 0.01. P-value came out as 0.025. P-value is greater than alpha. Decision, do not reject H0. Conclusion, at alpha equal to 0.025, 01, sorry, alpha equal to 0.01, there is not enough evidence to support the alternate that p greater than 0.5. Okay. Remember, a decision of whether to reject or not reject the null hypothesis is to compare the p-value and a preset or preconceived alpha, also called a significance level. In a hypothesis test problem, you may see words such as the level of significance is 1%. The 1% is a preconceived or preset alpha. When alpha is 1%, that means it's 0.01. You calculate a p-value, which is the probability of getting a test statistic as extreme as what you have obtained. If the p-value is less than alpha, then you reject H0. If p-value is greater or equal to alpha, do not reject H0. The statistician setting up the hypothesis test selects the value of alpha to use before collecting the sample data. If no level of significance is given, a common standard used to use alpha is 0.05. When you calculate the p-value and draw the picture, the p-value is the area in the left tail, the right tail, or split evenly between the two tails. For this reason, we call the hypothesis test left, right, or two-tailed. The alternative hypothesis H sub A tells you if the test is left, right, or two-tailed, it is the key to conducting the appropriate test. Example 9.11. Null hypothesis mu equal to 5. Alternate hypothesis mu less than 5. Notice as the symbol less than. Two slanted lines meet at an edge pointing to the left. Hence, it is a left-tailed test. The test statistic or the characteristic of the sample will fall in the left tail of the normal distribution. And the area to the left of the test statistic is the p-value as shown in this diagram. The highlighted area is the area to the left of the test statistic, which is given by that vertical line meeting the x-axis, okay, meeting the horizontal axis, okay. So it's a left tail test because the alternate hypothesis is less than. Notice at the next one, alternate P greater than, the two slanted line indicating greater than meet at an edge pointing to the right. So in this case, the test statistic or the characteristic of the sample will fall in the right tail, and the area to the right of the test statistic is the p-value as shown in this diagram. The highlighted area, the vertical line indicates where the vertical line meets the horizontal axis is the test statistic. Area to the right of it is the p-value. This is a test of a single population proportion. HA tells you the test is right tail. The picture of p-value is as follows. Now look at the alternate hypothesis, P not equal to. Immediately we know it is a two-tailed test. What does it mean? It means the test statistic can fall in the left tail or it can fall in the right tail. What is the p-value? If test statistic falls in the left tail, p-value is twice the area to the left of the test statistic. If test statistic falls in the right tail, then again the p-value is twice the area to the right of the test statistic. You should answer the following questions for hypothesis test example. H0, H sub A, remember this chapter we will conduct hypothesis on a single mean mu and single proportion p. State the distribution to use for the test. To perform test for a population mean mu, we can use either the normal distribution or the student's t distribution. To perform test for a population proportion p, we use a normal distribution. We will use the z-test, t-test, or one-prob z-test on the graphing calculator. What is the test statistic? If it is a z-test, it is a z. If it is a t-test, then it's t. If it's a one-prob z-test, it's also z. Sketch a picture and shaded region corresponding to the p-value. Graphing calculator, indicate the preset or p-concept alpha value. Compare the p-value with the alpha. Indicate the correct decision, reject or do not reject. Indicate the reason of the decision, p-value less than alpha, p-value greater or equal to alpha. Write an appropriate conclusion. Jeffrey, as an 8-year-old, established a mean time of 16.43 seconds for swimming 25-yard freestyle with a standard deviation of 0.8. So that's the population mean is 16.3, population standard deviation is 0.8. His dad, Frank, thought that Jeffrey could swim the 25-yard freestyle faster using goggles. Frank bought Jeffrey a new pair of expensive goggles and timed Jeffrey for 15 25-yard freestyle swims. For the 15 swims, Jeffrey's mean time was 18. Sample mean is 18. X bar is 18. Sample size n is 15. Frank thought that the goggles helped Jeffrey to swim faster than 16.43. That means the test hypothesis of what we are trying to establish is the alternate colon mu less than 16.43. The null hypothesis H sub 0 colon mu equal to 16.43. Conduct a hypothesis test using preset alpha equal to 0.05. Assume that the swim times for the 25-yard freestyle are normal. Swim times are normal. So we go to stat, press the stat button, then highlight means with the right cursor key, move the cursor to test, okay, on the top line. Then select number 1, which is z-test. The reason we took z-test because we know the population standard deviation is 0.8 second. Input mu sub 0, that is your educated guess. That is the hypothesized value of the population mean, which in this case is 16.43. What is the standard deviation is 0.8 given in the problem statement. So in the first line, input should be on stats. Okay. And mu sub 0 is 16.43, sigma is 0.8, x bar is given to us, standard mean of the 16 seconds for 15 swims, n is 15. And he is swimming faster than 16.40, so it is less than mu 0. And then you go down to calculate and hit enter. We get a test statistic of minus 2.08 with a p-value of 0.0186. What is the alpha value? Alpha is 0.0105. Conduct hypothesis test using preset. This is level of significance of 0.05. We are taking a maximum risk of rejecting H0 when it is true at 5%. Our p-value is 0.018, which is less than alpha 0.05. Therefore, reject H0 and we conclude at alpha equal to 0.05. There is enough evidence to support the alternate hypothesis H sub A, mu less than 16.43. Okay. The college football coach records the mean weight and that his players can bench press at as 275 pounds. So population mean is 275 pounds with a standard deviation of 55 pounds, sigma. 3 of his players thought that the mean weight was more than that amount. Okay. So alternate mu greater than 275. They asked 30 of their teammates for their estimated maximum lift on the bench press exercise. The data range from 205 pounds to 385 pounds. The actual difference weight where frequencies are in parentheses. That means 205 occurred 3 times, 215 occurred 3 times, and so forth. First, we have to enter the data in L1. So press the stat button. Then number 1 is edit. Then in L1, enter 205 3 times, followed by 215 3 times, and so forth. In total, there should be 30 data points. Okay. Now we go to stat, test, and we go to 1z test. Our mu 0 hypothesized population mean is 275. Sigma is 55. Our sample mean X, so our input actually should be this time on data. So in the first line, bring the cursor on data and hit enter because we have entered the data in L1. Mu 0 is 275, sigma is 55, list is L1, frequency is 1, so don't worry about it. So what is my alternate? The 3 of his players thought that the mean weight was more than. So bring it on greater than mu 0 and hit enter. Okay, so in the 5th line, bring the cursor on greater than mu 0 to indicate the alternate hypothesis is greater than 275 pounds. Remember, in the first line, you have entered mu 0 is 275. So in the 5th line, mu greater than mu 0 is your alternate hypothesis. The 5th line indicates the alternate hypothesis. And then we go to calculate and hit enter. Our z is 1.112. Our p-value is 0.133. Compare that with a level of significance of 0.025. P is greater than alpha. Decision: do not reject H0. At alpha equal to 0.025, there is not enough evidence to support the alternate. If you want to do a graph on this, so you go, remember this is a right tail test. So go to stat, highlight test, go to number one Z test. You have entered everything, so do not do anything. In the last line, instead of calculate, bring it on draw. What will this draw do us? It will show us a normal bell-shaped distribution with the test statistic falling in the right tail, and the area to the right of the test statistic is the p-value, area under the curve. So let's draw it. And you will see a nice bell-shaped distribution, and look at the p-value. The p-value is much greater than alpha or 0.025. How do I know that? Look at the blue area. It is much larger than 0.025. Remember, higher the p-value, if the p-value is high, H0 must fly. That means do not reject H0. Okay. Okay, let's do a problem on. Joan believes that 50% of first-time brides in the United States are younger than their grooms. Okay, she performs a hypothesis test to determine if the percentage is same or different from 50%. Joan samples 100 first-time brides and 53 reply that they're younger than their grooms. For the hypothesis test, she uses a 1% level of significance. So first we have to know what is the null hypothesis. So null hypothesis colon P population proportion is equal to 0.5, which is 50%. Okay, what is the alternate? Same or different from 50. So P is not equal to 0.5. So stat, test, highlight test. Now we cannot use Z test. We scroll down to one prop Z test, one proportion Z test, which is number 5. Align the cursor on number 5 and hit enter. P0 is what we are comparing to, is the status quo, is 0.5. What is my X? Number of successes is 53. What is my N? Sample size, 100. So X is always the small number compared to N, because X is a fraction of N. What is my alternate hypothesis? Same or different from. That means not equal to P0 is my alternate. So bring the cursor on not equal to P0 and hit enter. Then we go down to calculate. We calculate a test statistic and the corresponding p-value. Since this is equal to, not equal to, this is a two-tail test. Okay. So let's calculate. Z is 0.6 test statistic. P-value is 0.548, which is much greater than 1%. Higher the p-values, if the p-value is high, the null hypothesis should fly. That means do not reject H0 since p is greater than alpha of 0.01. Okay. So let's do this one. Marketers believe that 92% of the adults in the United States own a cell phone. A cell phone manufacturer believes that this number is actually lower. 200 American adults are surveyed, of which 174. So my N is 200, my number of successes is X, the smaller of the numbers is 174, report having cell phones. Use a 5% level of significance. So stat, test, when there are two numbers, it's a one prop Z test. Highlight test and scroll down to one prop Z test. My P0 is 0.92. My X, number of success, is 174. My N is 200 sample size. And cell phone manufacturers believes that the number is actually lower. So what is my alternate? Less than P0. Okay. And then I calculate. So I'll calculate a test statistic and then get a corresponding p-value. Test statistic is minus 2.606. What is the corresponding p-value? 0.0045, which is less than alpha of 0.05. P is less than alpha. There's low support for the null hypothesis. So P is less than alpha, reject the null hypothesis and conclude that at alpha equal to 0.05, there is enough evidence to support the alternate hypothesis. Okay. So what is the type 1 error? Type 1 error is reject H0 when H0 is true. Okay. Remember, my H0 is P equal to 0.92. We reject H0. In reality, H0 is, in reality, P is 0.92, but we reject H0. Reject H0 when it is true is type 1 error. And what is type 2 error? Failing to reject H0 when H0 is false. So we know P is not equal to 0.92, but we still do not reject the null hypothesis. Failing to reject H0 when H0 is true. Okay, failing to reject H0 when H0 is not true. Failing to reject H0 when H0 is not true is type 2 error. So type 2 error in this case would be failing to reject H0 when H0 is not true. Okay, that means P is different from 0.92, but we still retain the null hypothesis. We say P is 0.92. Failing to reject H0 when H0 is false, that is type 2 error. And what is type 1 error? Reject H0 when H0 is false. Okay. I'm sorry, reject H0 when H0 is true is type 1 error. So P is 0.892, but we reject the null hypothesis. In reality, P is 0.92, we reject the null hypothesis. So reject H0 when H0 is true is type 1 error. And failing to reject H0 when H0 is false is type 2 error. So I'll stop here today. If you have any question or comment, please write to me. You can also please check out all the problems that I have solved in my channel, Math Science Topia. So please subscribe to my channel, Math Science Topia, by hitting the red subscribe button at the bottom right corner. In my channel, Math Science Topia, I have a playlist called Stat Problems, where you can find all kinds of stat problems solved just for you. If you like this video, please give me a thumbs up. I appreciate that. If you like this video, share with your friends. You and your friends, please subscribe to my channel, Math Science Topia, by hitting the red subscribe button. And please do not forget to check me out tomorrow when I'll solve another math problem. Thanks for watching. Have a nice day. Take care. See you next time.